This problem starts off by telling us we have 9 total people that include a husband and a wife. All right, the minute we see something like this where they name people as being special, it makes sense for us to do this. Let's rewrite this and break those things apart. So what we really have is 7 regular people, and then we have 1 special husband, and we have 1 special wife. Okay, we're supposed to find the probability that both the husband and the wife are hired. So number 1, pretty straightforward. The denominator is going to be the total number of things in the sample space. That would mean there are 9 available people. We need to hire 2 of those 9 people. Now, why are we using combination and not permutation? Order doesn't matter in this particular problem. Now, let's think about this. They said that we're applying, these people, I should say, are applying for 2 different sales positions. In order to use permutation, in order to say that order matters, we have to know that the 2 sales positions are different from one another. Okay, so if you walk into Best Buy and you go to the computer section, there's any number of people there who are all effectively the same. They're all salesmen in the computers department. You go to a car lot to look at cars. There's a bunch of folks walking around the parking lot there. They're all salespeople. Their jobs are not distinct from one another. In order for us to know that we can use permutation and order matters, the problem would have to tell us that these were distinct sales positions or different sales positions. Or if they wanted to give us the most explicit sort of description, they might actually tell you what the jobs are. So a salesperson in furniture and a salesperson in electronics. But at the moment, we just know that these are sales positions. We can't discern that they're different from one another. So order doesn't matter in the problem. Okay. All right, so back to our problem here. We have our combination 9, choose 2. On the top, we would say I need to get a husband. There's 1 available and I need 1. And I have to get a wife. There's 1 of those available and I need 1. So on this problem, I end up with 1 over combination 9, choose 2. All right, the second one is a bit more tricky. Let's go ahead and write out what this means. It says that the probability that 1 is hired and 1 is not hired. This means that I either get the husband and 1 regular person, that's one possible way, or I get the wife and 1 regular person. So these are the 2 different ways that I could satisfy 1 is hired and the other one isn't. So in terms of our combinations, getting the husband, there's 1 available, we need 1. And 1 regular person, there are 7 available regular people, I need 1. I need this or, so I add a wife, there's 1 available wife, and I need 1. And a regular person. And notice how the English translates into the math. And means you multiply, or means you add. This is my numerator. This is all over the total number of things in the sample space. In this problem, that would mean the total number of ways to choose any 2 people from 9. So here are our answers.